morning. This is Suresh. See, in the previous example, we covered about the programmatic transactions, how we can write the programmatic way we observed. So, if you want to see the programmatic concept, so please like see the Spring transaction part 2 video so that you can able to identify. So, how we can define how we can write programmatic transactions. So as I said, the Spring is going to support two type two types of transactions. So what are the two types of transactions? So one is the declarative transaction, one more is programmatic transaction. So we covered about in yesterday class we covered the programmatic example. So today we are going to see the declarative transactions, how we can write it, right? So first I am trying to write information inside the like MS Paint. So, so I think it is easy to explain of once we know the basic concept, like what are the components are available to use Spring transactions, right? So first we will see those components. After that, we will see some example so that is it is easy to understand. So how we can use in real-time application the Spring transactions, right? So the declarative transaction previously is going to support to the EJB applications, right? EJB application in the sense EJB container. So like EJB container, we have the Spring container same like previously we have EJB container. EJB container. So the declarative transaction is going to support to the EJB container earlier days. So now the Spring people so like migrate to the using the declarative transaction to the Spring based Pojo classes. Spring based Pojo classes. So like so declarative transaction we can call it as. So the declarative transaction previously is going to support to the EJB container. Now it's supporting to the Spring Pojo related application. Pojo related applications, right? So now it's supporting to the Pojo related applications. So now how we can use the declarative transaction? The Spring provides three ways to declare the transaction. So how we can declare in the three ways we can declare the transaction, right? So the first one is using the Spring AOP, right? Using the AOP also we can use Spring transaction, and one more is XML declare transaction, and another one is annotation based transaction. So what are the three ways we can use Spring transaction? So the first one is AOP. First one is and second one is XML, and the third one is annotation. So these are the three ways. So we can use the Spring transaction, right? And so we like these are the three ways we can use, but before using the three ways, so we need some of the components. So how those components are is going to work. So as I said, the Spring is going to work based upon the ACI mechanism, right? So what it's contain ACI atomicity, consistent, and isolated durability. So these are the four components. These are the main four components the Spring transaction is going to work. So same like, so internally, if you are using the declarative transaction, so we have other components. So we will see, so what are the other components? So the first component called, so behavior. So first, what is the, so like in declarative transaction, we have five components are available. So what are the five components? How each component is going to work? So first one is behavior. So the first one is behavior, and the second one is isolation. So the third one is read only. Third one is, and the fourth one is timeout. So fifth one is rollback. So these are the five components are available in declarative transaction, right? So we can use Spring transaction in declarative transaction in three ways. Declarative transaction we can use in three ways. So these are the main five components. If you are using so Spring AOP or XML or any annotations, so these five components are main components, right? So now we will see each component how it's going to work. So so as I said, behavior. So the first the components name called the behavior. So what's going to do the behavior component? So the behavior defines the boundary of transaction with respect to the client. So like, so it's going to define some of the boundaries of transaction. Boundaries of transaction in the sense, so it's contained internally seven components. So the behavior is containing internally seven components. So what are the components we can see here? So the behavior is having seven components. So the first one is propagation mandatory. Propagation, sorry, we need to write in a capital letter. So propagation mandatory. So this is the first component, and it's having these seven components, right? So the second one is, so I'm copying this because every time it's taking time to write. So nested. So second is nested. Third one is never. So same like not support, not support, and required, required, requires new, requires new. The last one is propagation supports. The last one is supports. So these are the seven components are available in behavior. The main component called behavior component, right? So each component we will see how it's going to work. Like, so the propagation mandatory, the propagation mandatory in the sense, so what's going to do? So if you are writing this propagation mandatory, so see, the transaction we can define at the class level or method level we can define. So now I'm explaining in the method level. So we will see how we can define transaction at class level also, right? So first we will see the method level. So if you are writing the propagation, like propagation mandatory at method level, so the method must run with a transaction. So if the method is not having any transaction, so what's going to do? So the method is going to throw some exception. So for this, we can write the propagation mandatory because so while developing an application, so we can define, so we can identify, so like which method it's need a transaction, because if you are trying to add some method, so we can add some transaction information. So if you are trying to get some object, so I think we don't need to write a transaction because we are trying to get some data from the database. But while inserting the data, we need a transaction because so if you are trying to, if we have a multiple transactions, so they are trying to insert the same table, the same column. So what's going to happen? So the columns and rows are, the values are going to corrupted because so one transaction is trying to insert some 10 values. So the same column, again, the second transaction is going to insert 20. So what's going to happen? The 10 value is going to override with a 20. So if you are trying to get the values of 10, so we cannot get it. So for these cases, like inserting some data into the database or cloud application, we need some transaction. So for these, so if you are using propagation mandatory, the method not having any transaction, so we are going to get a some exception, right? So the purpose, so in this scenario we can use propagation mandatory. So the propagation, the second one is propagation nested. So nested in the sense, so the method should run with a nested transaction. Nested transaction means, so the method already having some transaction is going to like run with the existing transaction, right? So nested using the existing transaction is going to commit and to roll back. So if you get any exception, so the data is going to roll back, right? So if the existing transaction is not available, so it's going to create new transaction, right? Is going to create a new transaction and do some operation like committing or rollbacking operation is going to do. Like, so is going to create a new transaction in the sense, so the propagation required. So the propagation is going required also is going to create a new transaction. The same way in nested, in the nested propagation is going to do some two operations. It is going to do two operation. If the existing transaction is already available, is going to process with the existing transaction. If it is not available, is going to create a new transaction. So is going to perform two operations, right? So this is the behavior of propagation nested. And propagation never in the sense the current method should not run with a transactional. So the current method on the top of, if you are using the method, so that method don't run with the transaction. If you are trying to run with the transaction, so the method is going to throw some exception, right? So the propagation not support component indicate should not run with the transaction. So not support, what's going to do? So because already at the class level one transaction is running, right? So when if we run the particular method using the propagation not support, so what it's going to do? So if the new transaction is created for this method, already one existing transaction is running at class level. So what's going to do? If the so the method should not run with a new transaction. So the method should run with an existing transaction. So because this is the class I'm trying to create, So this is an add method, right? So this is an add method. So this is in our class, some class test we can call it as. What is going to happen at class level? One transaction is already in progresses. So when we call this particular method, what it's going to do? Here, new transaction is going to create. Here, one more transaction is going to create. So because in the class we are already having a transaction, so this method needs to run with an existing transaction. So for this purpose, so we can use the not support. So what's going to do? It will suspend for the duration of the method. Right. So if you are using the new transaction, if you are using the new transaction is going to suspend. Right. The new transaction is going to suspend, and the existing transaction is going to use. For these cases, we can use the propagation not support. Right. So same like the propagation requires, what's going to do? So the propagation required, so if you are writing at method level, is going to check if any transaction is already available. So it's going to use the existing transaction. If it is not available, so it's going to create new transaction. Is going to create new transaction. So this is the way the propagation required is going to perform, and the propagation requires new every time is going to create new transaction, whether it is already the existing transaction is available or not is not going to check. Every time the new transaction is going to created. And the propagation support, so what's going to do? The propagation support, so we can define this propagation support any method. The method did not run uh, transactional. For example, we can call it as a get method because we don't need a get method any transaction. So for this, if we require, if any certain cases, so the method is going to support. So for this, you can write the propagation support. But if you are using, so the by default, the propagation support does not have any transaction information. If it is required, so if you are trying to call the particular method, is going to support any transaction that is in existing transaction or it is in new transaction also. The method on top of it, wherever we are defining the propagation support is going to support with the particular method. So these are the 7 components are available inside the behavior main component. See, so I think you get some idea in which scenario we need to use these components, right? Because so if and you can imagine if you are trying to access some data, any e-commerce website, right? So in the e-commerce websites also, so what's going to happen? So both person can select single item. Both person can select single item. So in this case, what's going to happen? So the both persons can get a successful method. Can the e-commerce persons? So what's going to do? So who the item needs to send? They are going to get some dilemma. So in this case, we can define these many propagation so that we can provide some better performance. So how we can provide, we will see. And now we got some idea how we can use the behavior components, the 7 behavior components. The second one is isolation. So how the isolation is going to work. So isolation in the science, so already we discussed, so is going to support multiple transaction with the same data. With the same data, the multiple transaction can interact with the same data, but we don't want to get inconsistent result, we can call it as, because So multiple user may select. So what's going to happen? The e-commerce website people are going to lose, or the persons who are trying to get book some item. So those people are also may going to lose. So in this case, the isolation is going to work on the most important scenarios. So we will see how the isolation is going to work. So for this, I'm deleting. Again, I'm trying to write. Again, I'm trying to write isolation. So isolation 11, how it's going to work. So the second component called isolation level. So so it's defined how much transaction activities it's impacted on the current transaction, right? So the transaction may be impacted the activities of the current transaction, because so as I said, some we can example e-commerce website. Some they are trying to book phones, some any phone like iPhone we can call it as, right? iPhone 7. This is the new version launched in the market, because this iPhone they are trying to book multiple users called four users. So at a time, four people are trying to book on the iPhone 7, but so the three persons may last, only one person is trying, only one person needs to get the iPhone 7, right? If the four person get the iPhone 7, so what's going to happen? The iPhone person, they are going to lose their business, right? So they don't want to lose their business because they are having the one phone, and how, and they need to buy extra three phone to give the remaining three persons, right? So in this case, so the isolation level having some three components. Isolation level having three components. So what are the three components? First one is adaptive read. So the second one is non-repeatable read. Non-repeatable read. The third one is phantom reads. So for phantom reads. So these are the three components are available in isolation component. So we will see how these three components are going to work. So like, so as I said, the multiple transaction run with concurrently working with the same data, right? So this is the main component of isolation is going to work. So in the dirty read, what's going to do? So like for example, we have a one transaction, we have one transaction like, so so this is the transaction one, and this is the transaction two. The transaction one, what's it going to do? Read the data that has been written but are not yet committed by transaction 2, because he's trying to read some data from the any, it's the database or cloud, because the transaction is not yet committed. This the transaction 2 is trying to commit the some student object, right? Student object, because earlier the student objects having columns called id and the name of the student, some address of the student. So the transaction 2, what's going to do? Here it's trying to change the address from Hyderabad to Bangalore, right? So it's changed the address and is trying to save the data into the database. But before saving the data, the transaction 1 is trying to get the same data. So now in this case, what's going to happen? What is the existing data is available on the database. So that one is going to get it by the transaction one, right? Because so we are losing some information here, because if you see after 2-3 minutes again, if you are doing any database queries, so what's going to happen? We are going to see some different address, right? Because the transaction 2, what's going to do is trying to update some address. That's the reason we are trying to get some dirty read information, right? Dirty read informations we are going to get here. And the second one is, because here we are losing some our business impact information, we can call it as, like, because what's going to do, if you change some address, if you're trying to send any courier, because the courier is going to send the address, the previous address, right? But we need to send the new address in this the dirty read. So these kind of data we are going to get it. And the second one is non-repeatable read. So the non-repeatable, so what's going to do, so the non-repeatable, same thing here also. We have one more transaction, the transaction one called transaction 3, but the two transactions are inserting different data, right? The transaction 2 is going to insert the address Bangalore, and the transaction 3 is going to insert address called Delhi. The transaction is one is trying to get the data. In this case, is going to get the Hyderabad, or in this case is going to get the Bangalore or Delhi. So which address is going to get? Because, these three transactions are working on the same table, same column, right? So each transaction is going to get the different data. Each transaction is going to get different data. So this is known as non-repeatable read. So same, the phantom read also is like a non-repeatable read, but here, so here the transaction T1 reads some several rows. So the transaction 2 is inserting the some several rows, right? Here, because here it is working on the same single column, but the in the phantom read it's working on the multiple columns on the same table, multiple columns on the same table. What's going to happen? Same, like we are going to get the different data information. We are going to get the some different information. So how we can handle, because each time we are going to get a different information, right? So so we need to make the transaction isolated from each other, because so once the transaction is completed, if another transaction is trying to get or insert the data, so we need to get the all the transaction with the same data, right? So now in this case, what we need to do is having some components internally, right? So each how the components are going to work, we will see, right? Isolation default. So this is the first component, and read and commit. And the third one is read commit. Read commit. And isolation repeatable read. Repeatable read. The last one is isolation serialization. serializable, sorry. So these are the 5 components are available in isolation. So the first one is isolation default. So the default, how it's going to work. So as I say, default is going to work with underlying data store. Underlying data store means, so once the data is saved, then only the transactions 2 is going to get the another data, like updated data, right? So the second one is read commit. Read commit means, sorry, read uncommit. Uncommit. So the second one is read uncommit. So now, if I think you got some idea, isolation read uncommit. A transaction like, so the transaction 19, so the transaction 1 is trying to get this some data, right? The transaction is 2 is inserting. So because, so the data is like inserted into the database, but it's not yet committed. So those information, the transaction 1 is going to get it if you are using the transaction isolation uncommit, right? So the same thing, it's the opposite of read commit, because once the data is saved into the database or in any other file or cloud, the transaction 1 or 2 remaining transactions are is going to get updated data. And the fourth one is isolation repeatable read. So the repeatable read, so like it's going to work with the pattern reads. Like if you are using multiple transactions with the same data, or if you are trying to use one transaction with multiple times, right? So we need to get the updated data. In this case, we can use the repeatable read, right? Repeatable reads is going to work on the same fields or same columns, right? We need to get the updated information. For this, we can go for a repeatable read. The isolation, the last one is serializable. So is going to work on the ACID. As I said, the main component of Spring transaction ACID is going to work on this mechanism. ACID mechanism is going to work because if you are trying to insert some data, the remaining transactions are going to get locking. They are going to get some locking. So the locking, so it may be at row level, it may be table level. We cannot identify because, so here it is the student table. Here it is the student table. The student table having 3 columns, 4 columns, right? So based upon our transaction is going to get like make some locking at row level. Once the row level lock is identified, the remaining transactions are going to hold. So they may not get the updated data. They cannot interact with the particular column because already one transaction is trying to insert or update this some information on the particular row. Or we can provide the isolation serializable is going to provide locking at table level also. Once the lock is provided at table level, so the remaining transaction may not work with the particular table. So it needs to wait some certain seconds. So once the lock is released, the remaining transaction get. So in this case, what's going to happen? So the updated data, the remaining transaction may get, because so we can eliminate these kind of problem like dirty read and non-repeatable and phantom reads. We can eliminate these 3 kinds of problems using the isolation serializable. So most of the applications they are going to use isolation serializable. because so we need the updated data only. If anything is will updated data is not getting, so either e-commerce websites people are what we can call it as, so opposite person who they are trying to get some item, so they are also going to lose, right? So so in this case we can use to eliminate those problems, we can go for the serialization, serializable isolation, serializable we can use, right? So two components, the main two components are completed, and the third one is read only. So the third one is read only. So read only in the sense, so if you want to use some of the methods only read, like getting the data from getting purpose, so we can use the transaction read only, right? Because some all get methods we can like provide, so read only. So this is the, so the read only purpose. And the other one is timeout. So timeout means, so we can define some certain time, so to execute the particular transaction. So once the timeout is completed, so what's going to do, the transaction is going to roll back the some data. So what is the data they are trying to insert or update? So once the timeout is completed, the data is going to roll back. So in this case, so we can use the timeout options. And the final one is rollback. Finally, if anything exceptions occur, so the data is going to roll back. But the Spring transaction is going to work on the runtime exceptions, not on the checked exceptions. Because so we cannot identify at runtime which what kind of exception we are going to get, because so we may get so network related information or system failure information or bank related information. If you are trying to get some amount from the bank, so the person does not having any amount, so in this case also we are going to get some bank related exceptions. So the rollback is going to work on the like runtime exceptions rather than working on the checked exception. Checked exceptions, so at program level only we are going to handle, right? So these are the components are available in Spring transaction, right? And we will see example, so how we can use the Spring transaction. So if we want to use the Spring transaction, so first we need to use configuration. We need to change some information inside the configuration. So what information we need to change? Like, so this is our Spring configuration file. Like, so inside the configuration, we are going to write some information. Like this is the previous example of EH cache, and this is the some database properties we are using. And now we need to use some namespace. We need to use some namespace called Spring transaction namespace we need to use. So like, so we need to use two namespace called AOP as well as transaction. I'm copying the namespace. So what I'm defining here, I'm defining AOP.
This conference will now be recorded.
So we need to change to AOP. So why we need to add AOP namespace also, I will explain. And the second one is transaction. We can make TX, right? We can make TX and So use, we need to check the namespace is working or not. So how we can check? Just simply page not found. Okay, so close. So it's working. Right. So we need to get some information on the browser so that the name, whatever the namespace we provided, so the namespace is working as we expected. Right. So once we provide the namespace, we need to define some schema location as well. So where exactly the schema location is available, right? And what I'm doing, just I'm copying. So the previous one, again, I'm trying to insert. Just I'm copying, like adding AOP. Here also I'm AOP and changing to AOP. So you can check the AOP 3.1 XST is available or not. So like we can provide. So the AOP 3.1 XST already is available. So why we need this kind of namespace? So inside this XSD, they already provide some element information like advisor or point cut or config. So those elements we can use in our configuration file. So if you are trying to use the element name, so internal data, the container is going to load it. So for this, we need to use the naming space. After that, we can use our transactions also. Uh, tx, tx, we need to provide tx and check the tx namespace is already like available or not. So the tx also it's working. And so once we define the transaction namespaces, so how we can use, we need to see. So here I'm defining. So once we use the namespace, after that we need to use transaction enter space C, advice, transaction annotation divide, and transaction manager. So we are able to see these are the three tags are provided by the Spring TX XSD. If you copy these, we copy this annotation driven, just Control F and paste. So this element is already available inside the XSD. So whatever the information is all available inside the XSD, so those information is going to loaded by the container. For this, so we need to use the XSD, right? So now, so once we use the annotation driven, so we are like providing information to the container. So we are having some annotation related information. We will explain later. So first we need to use tx dot advice. We need to use tx advice, and we need to provide id name id equals to. So what is an id here? Tx advice. I am using tx advice. So we need to define the tx advice. So these tx advice we are going to use in AOP. So I will explain. Once we define the tx advice, internally we need to use attributes, tx attributes. So what are the attributes we need to use? And inside the attributes we need to use method name. So what is the method? Like we are defining add. I'm defining add. Again, I'm providing some star. So what's going to do? In any method is having the like add add we can call it as mm, add student, add employer, add person. So those methods are is going to get transaction. Those methods are going to get, and I'm defining propagation required. I'm defining propagation required. Propagation required in the sense what uh, so what we are going to get, so what when this method is going to call, the method need a transaction, the method need a transaction. So if the existing transaction is available, so it's going to load it by the existing transaction, otherwise it's going to create new transaction. So just we are defining the name of the method and the propagation is information, right? So and we can define one more transaction method, so that is we can call it as get star propagation. We don't need a required, just we need a support. We need a support. Support of propagation method is not valid with respect type is null. Okay. So we can read some information called read only. Read only true. We can make read only true because just we are providing get any get method. We need a propagation like transaction support. If we, in case we require transaction, the method can use the transaction, otherwise is going to ignore the transaction. So this is the way we can use these are support information. I need to check inside the transaction the propagation is available or not. So propagation here, so it supports is going to use supports, not support. We need to change to the supports. So like is going to work. So this is the way we can use, because if you see it's going to take as a string. So these are the values we can provide. If you are trying to provide other than these values, so we are going to get some exception. Like if I'm giving Java technology, so what is going, so because the Java technology is not available inside the existing, right? We need to give, so what are the values are available inside the XSD, so we can check. So using directly we can pass the paste the URL on the browser, we can identify the what are the propagations are available, right? So default it is required. So if you are using propagation or if you are not using also is going to take required. If you are manual, if you want to change anything, so we can use this. So these are the behavior, the components what we discussed earlier, right? Now the read only true, because the method whatever the get related method, so they are going to support only read only purpose. They are not going they are not going to use write purpose. So this is the way we can define. And if we want to use timeout also, we can use here timeout. Timeout one, we can give some seconds like 2 seconds or 3 seconds, or we can define. So we can see how the timeout is defined. It is a number or it is a string, where we can see timeout. So it's going to take integer, default is -1. So we are able to see on our configuration file. So whatever we are going to give is going to take in the seconds, not on the minutes or hours. It's going to take only seconds. We can define like 5 seconds. So the transaction is going to wait ideal 5 seconds. After 5 seconds, the transaction is going to roll backward. So this is the way we can use. And so as I said, whenever we are using the transaction, so we need to use AOP. So why we need to use AOP? So I'm going to like explain AOP, and if you know some of the concept of Spring AOP, so it is easy to identify. So what I'm writing right now. Otherwise, so we have in a video, so where we can find the Spring AOP. So how the Spring AOP is going to work? It is a different module. So you need to learn before, like if you want to know more information about the AOP. So simply just I'm defining AOP. So config and aspect, auto proxy and scoped proxy. These are the three components are available in AOP. So in our purpose, we are using config. So inside the config is having advisor, AOP advisor. So advise reference. So what's going to use advise reference? Like we need to use our transaction advice. So for this purpose, so we need to use our AOP, right? We need to define advice reference and so we can define our execution. So execution in the sense, so in which class method we can provide the transaction. Like, so we need to use point cut. Inside the point cut, we can use execution. So we can define execution like, so what is the method and in the which class we need to use. So simply I'm providing star because whatever the methods are available, so we can go for it in the student DAO class. So this is the way we can define student service. Like we can use in the student service, what are the methods are available. So all the method we can use our Spring transaction. So this is the declarative transaction configuration. So these are the main component we need to configure to use our Spring declarative transaction. And tomorrow we will see the Spring annotation configuration. And once the annotation configuration is completed, and we will see one example. So how the Spring transaction is going to work.